Understand the relationship of Fm inverse. In simple terms, I've already put it down here. All the x values becomes the y values of F inverse and vice versa. Okay, what does it mean? That means if let's say on your graph of Fx, right, there's this point 1, 2. In your F inverse x, this point will now become 2, 1. So this is called y equals to x. Sorry, this is the relationship between Fx and F inverse. So same thing, if you have a y-intercept 0, 5, this will now become now x-intercept 5, 0. Okay, so in the more simple terms, just remember number one, all the x values become y value and y value become x value, vice versa. Number two, there is a reflection on the line y equals to x. So for this, I'm just going to draw the graph first. Okay, I'm going to draw this line y equals to x. Okay, y equals to x. I'm going to draw the first graph, which is y equals to ln x. I'm going to use blue. Okay, you can plot into your GC, but you have to know that y equals to ln x looks like this. Okay, there's an asymptote. There's an asymptote at x equals to 0. So for y equals to e to the power of x, the asymptote will be at y equals to 0, and then it will cut over here, and then it will go continue to go all the way up. So technically, if you stretch further, right, there is another point of intersection that is going to be here. Okay, because this will go up here, as well as this will go up here, and then they will cut the graph again at y equals to x. So the grade one is y equals to f inverse x, which is e power x. Anyway, these two values, these two graphs are inverse of each other. Y equals to fx over here. What did you see? They will always intersect at this point. Okay, they will always intersect at the point y equals to x. They will always intersect at the point of y equals to x. So hence I put a cap over here. Y equals to x is always the point of intersection between f and f inverse. Number one, you must know both of them are reflected on y equals to x. Number one. Okay. Number two, all the x comma y will now become the y comma x. Okay, of the graph on any points. And number three, they will always intersect at y equals to x. Okay, later on in the next video, you realize that y equals to x, right, is also called f inverse. Or it could be f inverse f, doesn't matter. Okay, later on in the videos, you have to know. Then a learning point from this is, now since they all meet at the same point, question will always ask you this. Oh, find f equals to f inverse. Sometimes the answer for x is hard to find, or sometimes the inverse of this is hard to find. Okay, then to simplify things, we always use let fx equals to x. Because this is the point of intersection. Point of intersection means all the graphs are equals to each other. At this point in intersection, fx is equals to f inverse x, and this is also equals to x. So all these three are equal. Instead of using first two equal to each other, you can say fx is equals to x. That would always be a easier way to do it. Okay? Looking at this example, fx is 3x squared minus 1, and they specify the domain x greater equals to 0. So if you plot into your GC, negative 1 over here, you have to know that this is a inclusive of 0. So this is 0, negative 1, and it goes all the way up. Okay, so this is y equals to fx. Now, let's say I'm going to skip this part. Let's say the question didn't ask you to find the inverse. Sketch the relationship between f and f inverse and hence solve. And then this part, I'm going to say that, f inverse x equals to fx. Okay? Over here is 0, 1. When it is reflected on the line y equals to x, so you have to draw a straight line going up and label this as y equals to x. When it is reflected on here, 0, negative 1 will become negative 1, 0. Over here. Okay? This point, okay, not necessary to find, but if you can quickly use 3x squared minus 1 equals to 0, because that's the x-intercept. X equals to 1 over root 3. Okay, so this is 1 over root 3, and it will also cut here at 1 over root 3, and this will be 1 over root 3. Okay, the x-intercept will become the y-intercept. So now this guy will be a U-shaped curve in this way. It will, and then it is supposed to cut. So this is not like the best because it's supposed to be like a quadratic curve. Okay, so your 1 over root 3 bring bottom below. Or the best way is to, okay, I'm going to draw the quadratic curve first. Yeah, so I'm not going to draw the quadratic curve, right? Then I label here as 1 over root 3. Okay, so the green one is called y equals to f inverse x. You have to know the relationship between f and f inverse is a reflection on the line y equals to x. All the y coordinate become x, all the x coordinate become y from the original one to the inverse. Okay, next part, the question asks you to solve. Oh, when is f inverse x equals to fx? Question will always ask for this. Okay, you have to know that it is actually the point of intersection. And at the point of intersection, it is better to say that fx is equals to x. For this, we use fx equals to x is better. So 3x squared minus 1 equals to x. 3x squared minus x minus 1 equals to 0. It is always, you have to put it in the exact form. Okay, so x equals to minus b plus minus square root of b squared minus 4ac over 2a. 2a, and this is equals to 1 plus minus square root. This is 1 square, so this is 13 over 6. Now be careful. Can you see the point intersection is at the positive part? So I only need the positive one, so therefore x is equals to 1 plus square root 13 over 6. Why? Because x must be greater than 0 for this point of intersection. Okay, so 2 learning points. The relationship between f and f inverse is a reflection on the line y equals to x. Second learning point, when the question asks for f inverse x equals to fx, always use fx equals to x because the three of them will always meet at the same point.